Let us explain the Poinsot central axis, equation of Poinsot central axis in this video. We have a body where the pi represents the ith particle and it is made up of say n particles. And we have fixed a frame of reference xyz in space with respect to which we want to evaluate the equilibrium or the condition of equilibrium of the body on which capital Xi, capital Yi and capital Zi are the forces acting on this body parallel to the coordinate axis. So these are the three forces acting on at pi, the ith particle of the body, parallel to these three axes. To find the resultant of all the forces, what we do is that we sum them up and take to be x bar to be the sum of all the forces parallel to x axis, then y bar to be sum of all the forces parallel to y axis, whereas z bar to be sum of all the forces parallel to z axis. Obviously the direction is taken to be the positive direction of x, y and z axis. And now if we apply at this point origin equal and opposite forces amounting to x bar, equal and opposite forces along the y axis positive and negative direction, while equal and opposite z bar along this z axis. So obviously the net effect at the origin is 0 because they are equal and opposite and acting along the axis of x, axis of y and axis of z. But the ultimate effect on the body turns out to be a combination of a force as well as a couple. Why? Because this x bar, this y bar and this z bar to the positive direction gives us the resultant r square, which acts at origin. Let us draw it like this with a double arrow. This is r, the resultant of x bar, y bar and z bar, since they are acting through mutually perpendicular lines. We all know that if this represents x bar and this represents y bar, since they are perpendicular, the resultant is actually x bar square plus y bar square square root, and if we add them up with z bar, the resultant comes out like this, which we have represented as OR. And this line OR obviously makes an angle. This line OR obviously makes an angle cos theta, cos alpha, cos beta, cos gamma, or cos theta 1, cos theta 2, cos theta 3, whatever you say. The direction cosines are given by x bar by r, y bar by r and z bar by r. See this direction OR. So this we all know. But what about the effect of couple of this x bar and x bar along this? What about the couple of this y bar and y bar? They gives a jolt to the body. There is z bar and this z bar is acting to the upper side. This is actually the measurement of small zi, the coordinate of pi. This is the measurement of small xi, the coordinate of pi, and this is the measurement of small yi, the coordinate of y coordinate of pi. So the force x bar at origin to the negative direction of x-axis and the force x bar at pi gives a torque. So there is a couple. Now we intend to write the couple capital L, capital M and capital N about the three coordinate axes. Now if we start to evaluate the couple about x-axis and represent it by capital L, let us represent by capital L the resultant moment of the couple about this x-axis. Obviously we will have it as summation of yi zi minus zi yi. Why? Because this actually at ith point we have zi force, isn't it so? And whenever we have summed it up, it has given us z bar, summation zi, as you can remember. So here we are keeping the summation sign and we are considering the effect of the sum of the total couple for all the constituent forces. So whenever we are considering zi upwards and zi downwards here. So this has an arm. See, this body is here. So this zi and this zi has arm yi. This is the arm of the couple. And this makes the body turn to the opposite direction of the arm of a clock, anti-clockwise direction. So that is taken to be positive. And zi yi is negative. And since L is about x-axis, no x acts here, quite obvious, because x acts along the x-axis and it has no effect to turn the body about x-axis. This is physics. Similar, capital M may be written as, whenever we are representing capital M about the sum of moments about y-axis, I am not writing it here. L is about x-axis and obviously M will be about y-axis and N will be about z-axis. So whenever we are considering the rotational effect of couple or moment of the couple about this y-axis, so no y will come into play here, because capital yi, all the constituent forces along the y-axis cannot turn the body about y-axis. And here also we have the summation as zi xi minus xi zi, because this xi and xi couple tend to make the body rotate in anti-clockwise direction, whereas when we consider the arm to be zi, this is the arm of these two forces. These two forces have the arm zi, clear from the picture. And this has clockwise effect. There is a convention, I should say here, that if you represent this as 2 second axis and this as 3 third axis, so this is the even permutation 2 to 3 and this is the odd permutation 3 to 2. This is the even permutation 3 to 1, 1 to 3 and then 1. So this is even permutation, this is odd permutation 1 to 3. And similarly, when we consider the sum of the couple about z-axis, capital N denotes the sum of the couple about z-axis. This is x, this is y and this is z. Then we don't have z and we have only xi and yi. And obviously, according to the convention, xi yi is positive and yi xi is negative. So that is how we calculate capital L, capital M and capital N. And we should also remember that the resultant of these two couples, since they are about the three mutually perpendicular directions, their resultant will be g square equal to L square plus n square plus n square, and the resultant couple will have an axis with direction cosine given by obviously capital L by G, capital M by G, and capital N by G. So whatever be the constituent forces, we have reduced them to a single force capital R and a single couple capital G. Isn't it so? Now let us look at the geometry in a greater detail. This is origin, and we have a resultant R and a resultant force rather R and a resultant couple G. This OR has direction cosine capital X by R, capital Y by R, and capital Z by R, while this resultant couple has the axis with direction cosine L by G, M by G, and N by G. Now our intention is to find a single line which will be the Poinsot central axis and which will represent all the resultant force and the resultant couple of the body. Here we have the resultant force along a direction and resultant couple along another direction, and they have the angle theta, which will obviously be given by cos theta will be equal to, you all know, Lx plus My plus Nz by R into G. Isn't it so? This is our this is our angle between these two directions. This is clear from our notion of 3D geometry, and this is a very important expression, which is why I write it at the top of the board. Now, what is our intention? Our intention is to find a single line which will be termed as Poinsot central axis. But here we have reduced all the forces to a single force R and to a single couple G whose axis is OG and which both the direction has an angle theta. Now we reduce this couple G to G sin theta and G cos theta. This is easily doable since these are two perpendicular directions. We resolve the effect of this couple to the two perpendicular directions, and then we choose a parallel distance OO prime. This is actually projected from this board. This is perpendicular to the plane of the board, perpendicular to both OR and OG, and we choose to apply at this point O prime equivalent opposite force R. This O prime, the distance is measured or taken as G sin theta by R. Then what happens? It's very interesting. I am applying equal and opposite force at a distance O prime R. So they have no effect altogether. But what is the effect of the whole system? See that we have actually a force R here and a couple RR. And what is the moment of the couple? It will be G sin theta by R into R. Isn't it so? Because this is the distance and the forces are R and R. So what we are left with? We are left with only a force R along this and a couple G cos theta along the same direction. Isn't it so? These two are parallel direction, and this will be termed as G, Poisson's central axis. And the system reduces to a force R and a couple G cos theta. Now what is the value of G cos theta? We can easily look here to find that the value of G cos theta is Lx plus My plus Nz by R. Isn't it so? From this relation. So what we have done? We have found out a single direction through which the resultant force R and the resultant couple acts, and this twin is termed as range of the system, and the direction or the line through which these two acts is called Poisson's central axis. Now let us see how can we find the equation of this Poisson's central axis, or the line through which the system acts, which is termed as a range. Just think of the previous picture, what we have drawn. You can easily remember that we have a body here and we have a frame fixed here, isn't it so? And we have reduced all the forces to a force R and a couple G, and then we have found out a particular line which is at a distance from this R of an amount G sin theta by R, which we term as Poisson's central axis. Now what will be the equation of this Poisson's central axis? Let us take a point alpha, beta, gamma as current point on central axis. So alpha, beta, gamma is a current point on, I am not being able to draw the central axis here. This is a distance this apart shifted to here, through which both R and G cos theta acts, and we termed it as range of the system, to which all the forces are reduced, a force and a couple acting along a single direction, unit direction, and we have taken a point P, alpha, beta, gamma, on that line only. This is a current point, and we will try to find the equation of the central axis with respect to these 3 points only. This you can easily apprehend. Now just consider what will be L prime. Since this is our original O and it is shifted and the new coordinates are alpha, beta, gamma, so since we have taken this as x, y, z with respect to this origin, we just shift the set of axis from this O to O prime, which is at a distance G sin theta by R apart from distant from O. We shift the origin to this point, and what will be L prime? L prime will be nothing but summation of y minus beta z minus z minus gamma into y, isn't it so? Just remember that what was L? L was when we considered the moment of the force, all the forces about this x-axis. What we have written? We have written logically that L to be yz minus zy. And so obviously from this we may write that L prime, which will be the moment about the frame of reference which is shifted from O, having coordinate alpha, beta, gamma, like this, because we have shifted the origin. See, we have written y minus beta here and z minus gamma here. So it is quite apprehendable, isn't it so? And from similar logic, we may write m prime as summation. What was m? M was nothing but, m is the sum of the couple about y axis. So m is nothing but summation zi xi minus xi zi. And here we have obviously z minus gamma capital X minus alpha capital Z. And similarly n prime will have expression like, since n is nothing but xi yi minus yi xi, so we write x minus alpha into y minus beta into x. This is simple. We have just shifted the origin and replaced the coordinate with respect to alpha, beta, gamma. Okay, so let us replace this summation, because here we have not used the index I, and replace this z, all the forces, by the sum of the forces. You all remember that summation xi is actually x bar. So this is L prime, M prime and N prime. Now just see that L prime is nothing but, from this, since this is yz bar minus zy bar, we have L prime equal to L minus beta z bar plus gamma y bar, and M prime equal to M minus gamma x bar plus alpha z bar, and N prime equal to N minus alpha y bar plus beta x bar. So these are the three expressions which we have. Now let us move on, or remember that what is Poinsot central axis? Poinsot central axis is a line through which both r and g cos theta acts, isn't it so? Both r and g cos theta acts, and you must remember the expression cos theta is equal to Lx plus My plus Nz by Rg. You must remember this. And since this g cos theta and r, the system termed as range, acts through central axis, we may write easily that x bar by r is same as this L prime by k. What is k? K is this g cos theta, because they are the same axis, and g cos theta or k has this expression Lx plus My plus Nz by r from here, isn't it so? Similarly, y bar by r is equal to M prime by k, and z bar by r is nothing but n prime by k, where obviously k is the resultant of all this L prime square plus M prime square plus N prime square. It is quite obvious that, because this L prime, M prime, N prime are the resultant couple after we shift the central axis to this point to a distance g sin theta by r. And since this r and g cos theta lies on the same central axis, their direction cosine will be equal, and we can write this. And from here, from this, we can easily write the equation of central axis. How? We will just write this in place of L prime and keep x bar here, then it will be k by r, and we will write this in place of m prime here. We will put y bar here, and this will be k by r, and similarly n prime by z bar will be k by r, and we can easily write, just see, I am keeping this set equation and this set equation here, and from here we can write that L prime is nothing but L minus beta z bar plus gamma y bar by x bar, and that is equal to m prime by y bar. M prime is m minus gamma x bar plus alpha z bar by y bar here, and here we have n prime by z bar. N prime is nothing but n minus alpha y bar plus beta z bar by z bar, and they are all equal to L bar by x bar is equal to k by r, m prime by y bar is equal to k by r, and n prime by z bar is equal to k by r. So they are all equal to k by r. Okay. Now just take note of a thing, that this is termed as equation of central axis. Simply if we replace all these beta, gamma and alpha by the current coordinate, say x, y and z, you see that capital X bar, capital Y bar and capital Z bar are the forces along the x axis, y axis and